I actually just have a question for, for the Pinatubo case, which I think it's interesting because um, it's about a crisis that wasn't expected somehow. So I just wanted to ask um, if I got it right. I'm not sure. I noticed that at the time of the dome extrusion, day 6 and 7 of June, the level was 4, so it was not eruption, but was just one below eruption, that is 5. If I So my first question is, why was that not an eruption if a dome was forming? And second, that the level actually dropped afterwards for a few days back to 3, and then eventually went to, if I got the right, anyway. So that's the first thing. The second one is, why did you choose in your ranking of alert level to give a time of 2 weeks? Let's say that those 2 weeks, based on what and with what kind of let's say responsibility you decided to take that time window.
First of all, on the chronology of the alerts, alert level 4 was declared on the morning of June 7, before the dome began to grow, and then the dome began extruding late that afternoon. So we do consider that an eruption. It's just that it happened on the same day, so it looks close together. The alert level did not drop after that. It remained at 4. In fact, it was raised to 5 on June 9. Now, about the 2 weeks, I'm not sure I know the answer for that, but I think it was because we thought that would be a kind of a useful planning period for the public who might need to be evacuated. As I indicated, it was a complicated socio-political setting. We had the large Philippine lowland population. There were the 20,000 indigenous Aitas who lived up on the volcano, who in general wanted nothing to do with the lowlands. They distrusted everybody from the lowlands. And then there was the military. And all of these different groups required some convincing. So we wanted to, I guess we wanted to start them thinking about, what they might do and where they would go in 2 weeks.
For the alert level, we reserve the eruption as the hazardous eruption. So if it's just a dome building activity, we don't raise it to. We know it's an eruption, but we have to think of the warning as a message to the people. For scientists, it's an eruption, but the warning is reserved for the people. So if you say eruption in progress, it's a dome, they would not believe that there's an eruption.
Okay, Stefano.
Well, thanks everyone for very interesting presentations. I have just a question for Professor Newell. You show us the probability event 3 you perform before the eruption, and I understood that you assign 100% to big eruption due to the past history of Pinatubo. And I wonder how you assign other probabilities to other nodes. So did you perform sort of elicitation, or maybe just a differential diagnosis, brainstorming between scientists? How did you choose to assign 70 instead of 60, maybe? Thanks.
First of all, we didn't assign 100% to the having a large eruption. I think it was 70% chance of large, 30% of small. Now, how did we choose those numbers? There was no expert elicitation. We were all just running completely ragged. We were working 22, 23 hours per day. And it was, there was actually very little discussion. Just a small group of us sat down and brainstormed, including Ray Puddingbayan, who was the director of VUELCO. But it was absolutely not a rigorous process. These days we can do much better. It was not random guessing, though. It was based on trying to find a few data sets that we thought were relevant. For example, the eruptive history that we knew from Pinatubo, but also recognizing that there could be smaller events. So we looked at a few other volcanoes like Pinatubo and built that in. But they're very rough numbers. I'll be the first to admit that. I think it helped, particularly with the military and with the then director of Philippine Civil Defense, Engineer De Horas. I should add that we did not show any of this to the press or to the public or to any of the political officials. This was used exclusively with the civil defense and military.
Okay, any further questions? I've got plenty of bullet points that I noted down, but I'd like to invite you guys. Yeah.
I would like to ask the panel, which are the challenges you think potential large eruptions on cities, large cities and large developed centers are? Which are the sort of the major issues related with volcanic hazards on large cities? And I suppose Mr. Curcio is directly.
I've been talking to many people, different sorts of economic status, and bottom line is, if you talk to people living in urban areas, they're more difficult to convince. I think they're busy, they're educated, and sometimes because they're educated and busy, they think that they know that they can handle the situation. But that's, I think, the challenge if you have a very large eruption in a big city, is how to convince them. So, what do we do? Our style is, for example, I talk to big companies, I talk to businessmen, I talk to Rotary clubs, so that we can influence them and they can influence the rest. And increasing the awareness of people in the cities would really be a challenge. Those in the rural setting, they are very accommodating, just like what happened in Pinatubo. They would listen to you and they would follow your suggestion.
I think that this kind of problem we can test more easily in a lot of other risks, more common, more democratic. If you ask to people who live in Rome to stop their jobs for 1 day or 2 days because maybe it's going to snow, it's much easier, but they will not stop. I mean, urban society run very fast, and I completely agree. We, because we are urban society, are not really well connected with the risks and with what nature can give to us. Also with the other risks that are more common.
Yeah, if I could just add, and I think it's a point that everybody here is very conscious of. When you have a large population in an urban setting, and you need to evacuate, it's going to take time, and the the earlier you recommend an evacuation, the higher the uncertainty that the volcano is actually going to erupt. And sometimes you don't know for sure that it's going to erupt until maybe hours or just a few days before the eruption. And that might be too late for an evacuation of a big city. So that's a huge dilemma.
I was simply perhaps trying to add this other dimension that we talked about, the stress testing, and that was Fabrizio mentioned earlier. The question I think he raised was, what does it mean to test a large-scale scenario? You know, we talked about this a bit earlier, so maybe we can direct the discussion into this direction a bit.
Yeah, we have tested, as I said before, also with the exercise, also in volcanic risk, but there is not the feeling of the real situation. When you are going to deal with the 3,000, 300,000, 600,000 people, you know, the real situation is really different from an exercise. You can imagine that also recently we have done an exercise with another kind of risk. We talked about tsunami, and talking about the risk, people are not really interested sometimes in what we are going to say, because it's going to say, okay, it doesn't happen. So you can imagine where you talk in a region like Campania, in a difficult urbanized site like the province of Naples, where today problems are really daily problems. You're going to say, okay, maybe when it will be, you should have make an evacuation. So people are not now really interested in that. So we must work a lot, because the awareness is strictly connected with the risk and with the perception of the risk. At this present moment, there is no perception of the risk, so they have other risks, and they have other perception of the risk. So it's very, very hard to make a real test on that. We wonder if it will be a really mass evacuation if people see something. Maybe they see, you know, on the Vesuvio some gas, so which will be the reaction of the people? We can imagine that, but we don't really know. They fall away and say, okay, I want to go away or not? Or, no, it's no problem. It's quite difficult to make this kind of discuss when you are talking about 600,000 people.
Okay, there's two questions here. First, second.
No, what was just about this meaning. In my opinion, for testing 300,000 people emergency, as Fabrizio was saying, is very difficult in practice. But we have, for example, tabletop exercises that are used exactly on this purpose. Of course, you cannot test people. You cannot move people in such, but you can make tabletop at different level. You can have a tabletop at national level. You can have tabletop at local level, and all levels you want to test. And also, from the other side, what Fabrizio was saying also is the awareness, increasing the small exercise in schools and public ministries and so on. So, in a certain sense, you prepare the society to react to an event that you cannot even predict, even manage at that moment. That's my point. Thank you.
Funziona? Okay. Please, I was struck by this reaction of the army officials that changed when you decided to move your observations point from one side to the other. So apparently the way in which scientists behave becomes an important message given to population. Is that correct?
Yeah, yes, it's absolutely correct, and we have seen it now in another place as well. In Montserrat, the scientists were originally in the town of Plymouth, and they moved to a safer location away. I think it's a very strong message, and I think in general, scientists are always wanting to work in close to the volcano and go put in instruments and look at the deposits and so on, and we have to recognize that local people are watching us, and if they think we are not concerned, then they will not be concerned.
I would like to underline another thing that we are facing, I think, very recently, that this is what is the web society and the social network will deal with the situation. We often have to face as a civil protection another kind of risk. Tomorrow will be an earthquake, and there is a web communication and mass people that are going to know each other talking about that, and so you create a mass situation, a mass feeling. So maybe we must think also about that. How I would not say control, because it's not the right word to use. How we can deal with the social network when the social network is the first time that you give the information. We have the same problem with earthquake. It's the first notice, it arrives on the social network, and then the institution run up to reach the information, because everyone can put the information on Twitter, but the institution has the responsibility to check the information. That's why we always run, because, okay, I just say it will be something, or it's happening something anywhere. I just write down. We are an institution, we are not right, we have to check and then give the right information. So you can imagine like a volcanic risk when there is the possibility to say that something is going to, but we are not sure that when, we are not sure what, we are not sure how big. I think that this must be another process that we must think about, because it's a really world process.
Okay, thank you. The questions? There's one there, one there.
Yes, I would like to add something on this, because in this session we have seen two different examples. One is of Pinatubo, in which the precursorial phase lasted for 2 months. The other was the Uzu eruption, which lasted 3 days. And the problem with us is that we are always have the idea that the main problems is forecasting the beginning of the eruption and perhaps how big it will be. Instead, probably we should start thinking that we are trying to study a process which can last for periods of times, depending perhaps on the size. I don't know if a large eruption requires 2 months to build up. Probably we have seen that in Pinatubo, the real build-up was the last day, was only the last day. And that's the major problem. For example, if we go to Campi Flegrei, we saw that a small eruption, the precursory phase lasted 100 years. And the more we know, we study of volcanoes, probably we can have a sign. So how can we deal with these problems, especially in a urbanized environment like that of Naples, in which we will not be sure that an eruption will occur until the last day? And so probably I think we must have a different approach to the problem of evacuation or dealing with volcanic risk. And I suspect that we should aim more to the education of people and to people being more self-sufficient, to be able to know what to do in case of eruption. Because I'm quite sure that we will not give any advance warning for evacuation of 500,000 people.
Some very interesting points, and I invite the panel to respond, because I'm only the chairman. I'm just delegating here.
I agree. I mean, this is what we are calling resilience of a society. And we must build the resilience of society in each kind of risk. But we are turning around the problem, because the resilient society, you can imagine that you can do a resilient society in an awareness society. If you are not a good level of awareness, you cannot be resilient. This is something that doesn't work. So, and now we are still on the first part of the speech. I mean, the first step is to increase the awareness. To increase the awareness, you must put near the citizen to the problem. So to let understand to the citizen that that one is his problem, one of his problems. If we do this, then you can get closer also with the institutions, because we must think that institutions, mostly in this period, follow often which are the needs of the citizen. So if the institution understand that that one is a need of people, they are going to invest on that. It's a circle. It's quite a circle. We must take the very first part of the circle and begin. We are still going on with information, teaching, meeting people, meeting major, workshop, talking about the question, talk about the problem, and what our friend was saying, never lose about the hope.
Well, if I could pick up on the last thing, never lose hope. Roberto, you're very pessimistic. I'm not so pessimistic. I think in almost all cases, we will know that the volcano is restless. We may not know exactly how long that fuse is. We won't know exactly when. But we will know whether the activity is constant or accelerating. And clearly, if it's accelerating, that's increasing the probability of an eruption. I do agree with you that it's dangerous for us to try to forecast exactly when something will occur. I think the 2 weeks, the 2-week window we used, the 24-hour window we used, those are rather risky, and I'm not sure we can always achieve that. But we can, and I think in an urban setting, we must try to go through a rigorous estimation of the probabilities of eruption and the probability gain. And I think that is possible. The other comment I would make is it's not inconceivable to evacuate 500,000 people. It was done at Marapi in 2010 of 300,000 people overnight. It was done in New Orleans with Hurricane Katrina of 1 million people plus minus. It was not a very clean evacuation, but it did occur. People were able to leave, and I think we have to be prepared to actually try to give people advice. Maybe one of the solutions, I've worried about this a lot myself. Maybe one of the solutions is as it's clear that the probability is increasing, simply let people know that and let them start to make their own decisions and self-evacuations. So it doesn't have to all be in one quantum jump.
Sorry.
A Japanese perspective on this?
Because we have also big cities nearby to the volcanoes. Something like Sakurajima is one of the place. Sakura recently so active and changing its behavior, that we know. And volcanoes telling to the society and civil defense, different type of eruption is possible, is right now, is a stage. But it is not so clear to the people or the population outside of the island, to the Kagoshima city part. They don't understand what it means. So actually quite difficult how to communicate to transfer our uncertain message to the big cities. Same thing is a case of Mount Fuji. Mount Fuji is always repeatedly, intermittently concerned for the journalists, mass media's target, as well as real discussions. And concerned people number is very large number, and traffic route is very limited for quick transportation. So I didn't think about whole Japan scale problem. I'm living in countryside. In Hokkaido, we suffered more commonly much smaller or medium-sized eruption, like VI up to 3, 4, not thinking about 5. But all depends what is a precursory phenomena will be. VI more than 5 is completely different. Small eruption itself is a precursor to major eruption. This is the differences. So that gives us some more time limit, time interval to prepare. So we need a complete catalog of Splinian type large eruption, how it's developed in the coast, and how scattered the data is. So such data is very important. We have to communicate the big cities, nearby volcanoes, to using such information. Thank you.
Guido?
One interesting thing for me today was to see how many different hazard maps have been used in different type of situations. And some of those relatively simple, some of those more complex, some of those very complex and based on very different things, from guessing to deposit distribution, to including numerical modeling, and wind dispersal, everything. Now, my question here to the panel and to everyone is whether we are willing to somehow, reason about what are we using and what for? What is the effectiveness of doing things in a way or another? For example, clearly the hazard map is tailored for designing areas to be evacuated, but also, they could drive lines of intervention, and they do at some stage. And given this, the purpose, what is the level of detail we want to have? What is the level of confidence we want to have? Whether, some very detailed modeling is actually going to help or make a problem into, because I was actually quite interested in seeing that in several, like even deciding the level of alert seems to be more driven into communication than the actual things. So you say, yeah, the eruption has started, but we decide not to say that. We say that later when people actually see that. Otherwise, so what I'm saying here is that the hazard maps are communicating tools. So the way we build them, the way we use them, and to have a clear idea what we are doing, I think it's important. And maybe, for example, for me today, there is an overestimation of the some probabilistic approach, which are good and they can be used for specific issues, but maybe not that necessary to overcome other tools that we more commonly have used in the past and seems to be effective as the deposit or even the judgment of the experts.
Okay, thank you. So it's about hazard maps, value, the detail, the complexity. Who wants to go first?
I'll just make a couple of brief comments. First of all, it's true that the old-fashioned hazard map based on deposits actually does quite well. There was discussion of this issue at the workshop that was just held up, the Volcanic Observatory Best Practices in Erice, and there is going to be a workshop held in several days just before the COV8 meeting in Yogyakarta next year, convened by Eliza Calder, and the purpose is to review all the different ways that people make volcanic hazard maps. What are the assumptions that underlie those? What's the basis for those maps? And I might add that although we don't usually acknowledge it, there's actually some implicit probability in a hazard map where when you decide where to draw a line, you're making a judgment about whether you're aiming at the 99% certainty or 95 or 80 or whatever. It's not quantified in quite that way, but I think there are many ways to make hazard maps, and this review next year may be quite useful.
Well, deciding what type of hazard map you would use, whether it's geologic or probabilistic, is really dependent on the audience that you're talking to. We just produced probabilistic maps of severe wind, flood, and earthquake, and the mayors didn't understand it. The politicians didn't understand it. We share also this with the land use planners. So they really have a lot of questions, and so we must really prepare our audience on these different types of hazard maps so that they can understand it, so that they can use it according to the purpose that according to their job, right? So I think for just evacuation, it worked pretty well in many of the eruptions in the Philippines and even in Indonesia and even in Japan. But if we look at other planning purposes, then we might have sophistication a little bit in the maps that we would show.
Some volcanoes has many different size assumption. If you assume the scenario, hazard map is different scales. But some other volcanoes has only, most of Japanese volcanoes may be largest likely scenario. But it is not my opinion. Assuming the size is must always linked to the probability of that phenomena. So even smaller eruption that may affect people's lives and properties, it is necessary to prepare, like volcanic gas or rockfall hazard map. But in other case, caldera forming eruption is a completely different scenario. We have to tell them the probability in general, in worldwide, as well specific in that area, if that is known. But the problem is mostly case we don't know the sufficient statistical data in certain volcanoes. So in that case, I still don't know how to assume the size is. For the case in Hokkaido volcanoes, that all of the hazard map I involved directly, so I know the basic scheme, what we think about that. For example, Mount Usu had erupted in 1663 VI5 events. But we are not using that VI5 for the making the scenario, because VI5 event is only once. After 7,000 years dormancy, just 350 years ago, it is the starting of the recent volcanism, starting rhyolite and losing silica component, with then changing to rhyolite now. No, dacite now. So we assume the most damaging effect eruption in 1822 is a case scenario, because everybody mostly agree it could kill many people even this century, and eruption probability is not low. But the size of VI5, starting of the after 7,000 years dormancy, that probability should be not so high. That is our judgment. Another case is Mount Tokachidake. Tokachidake erupted. It's not the size of the eruption, but snow melt lahar is a major problem. So in that case, still we are not using the same scenario in 1926, because 1926 in central cone was heated and collapsed and mixed with the snow, and producing the snow melt lahar, large scale. And already that part is no more existed there. So next to snow melt lahar, probably the scenario is large pyroclast flow. So in that case, the probability is much lower than before. So that is in mind. So in general agreement for making hazard map at Tokachidake, that volcano, is assuming the 1926 size. It is quite actually large influence to the settlement. But still, it is idea because people knows very well about the tragedy. And the people wanted to prepare that, so that awareness. So we use that size for the preparation of that one. But we also informed people and officials next eruption if it is a snowmelt Rahar. But the mechanism may be different from the previous one. So each case probably completely different. For the Meyakandak volcano, eastern part of Hokkaido, we have 3 levels of hazard map. One is a pyroclastic flow, probably once or several thousand years. And the second one in the middle size. And one is much smaller one. Only near to the volcano may have influenced. So I think thinking or planning the size of assumed eruption size depends on each volcano's history as well as possibility of that probability. Thank you.
Okay. Thank you. We've got one question there. Siri.
Thank you. I would like to address my question to Professor Fabrizio. In one of your slides, you mentioned about elaboration of emergency plan, and one of the steps is involvement of other region. Other region within hazard zone area. Do you include also a safe zone area related to evacuation place? If it is, then what problem that you face during doing exercise? Thank you. Okay, involvement of region in hazard zone area. Do you also involve region in safe place related to evacuation place? And if it is, then what problem do you face during exercise? Thank you.
I'm not sure to have understood very well the question, so maybe I can move my answer. But the question is how we deal with the other regions during the twinnings or with the region, Campania region for the hazard. The problem is how we deal with the other regions. Yes, is this a question? The question is how we deal with the other regions, with the twinnings, or how we deal with the Campania regions about the scenario or something like that. This one. Okay. All the scientific information we shared with the Campania region. We are, I could say, the national focal point, if you can use these terms, and we deal with the scientific part and we transfer the information to the Campania region, and with the Campania region we make the strategy, operational strategy, and then we inform the measure. But how I say before is the Campania region in that case that is on charge for the dissemination of the information to the people. For the twinnings, we have just done, simple division about the people and about the how big is the region who is going to take the people from the south. And we just put together region with the municipality. So we are not going to divide the municipality. For example, if we have got Palma Campania, who is a district, we just move all them in one region. So we just put one community in one region. And now we are dealing with them because, obviously, we cannot hide that behind this kind of questions there are financial problems. I mean, the regions who are going to take people, we say, okay, we are going to take them, but who is going to pay for a long time? This is another question. We are going to evacuate, okay, but for how long time we are going to ensure people in my region will be 1 week, 2 weeks, 1 month? And when you are going to plan that, they would like to know this. And obviously, we are not able now to say this because this is we will know this when the event will occur. In that case, we will know how long will these people stay outside their house. So also this is a quite important issue that we are dealing with the region, that we are involved in the twinning. For the other question, I mean, Campania region is our partner on that. We cannot do things without involving Campania region, just because, as I said before, the law say that the region is the principal stakeholders of what is going in civil protection we do on that territory.
Okay, thank you. There was one question there. We will take this now, and then I was perhaps finishing up with the other question that I think we should perhaps briefly address, and that's the issue of so-called false alarms in our communication of volcanic risk. So let's have that, your question first.
Just briefly, I would like to come back to the question of 3 days, 1 days, forecasting 15 days of a crisis, and etc. And I think that we have to learn from countries that had a lot of emergency in the last century, of course. We learn, for example, from Philippines and from Indonesia. Indonesia is doing something that it seems very working, it seems very good. So they were doing what they call socialization, that is a phase that is very close to the alarm, so is in the pre-alarm. Doesn't matter if this phase can last for 3 days or 30 days, better if it's 30 days, you have more time. But in this phase, there is really what they call not information. Information looks something that I give to you. But this is really sharing of knowledge, sharing of what is occurring, and it is done in capillary part, in every family, in every, and etc. This is the goal. I don't know if they succeed in everything, but this is the goal. So I think, for example, in Campi Flegrei or in Naples, so in urban areas in which it's very difficult to raise awareness on a very huge, very high level, because usually in urban areas, etc., especially in some countries, you have a lot of problem. People, the priority of the volcanic eruption is absolutely not at the maximum, but it's a very low level sometimes. So it seems working very good to have a plan for having a very strong phase of socialization when you start in pre-alarm phase, and the preparation of socialization phase is itself a crucial part of education of people. To prepare such a phase, you have to work a lot of time with the professors and public administration and etc., because you have to ready to perform these phases. So I think that this is something that can help in the process of if you have enough time to apply these phases. And always, of course, but I don't say to Fabrizio knows very well, of course, if you have 1 day, we have to build alternative plans. So as Chris Newell was saying, there was evacuation of 1 million in 1 million people in one night, and we have, of course, to build an alternative plan if something goes wrong. If something is not giving us the time to apply something that can say socialization phase or something like that, we just pass to attention to alarm and evacuation in one night, and we have to be prepared on that. These, in my opinion, are two crucial things that if you do these, probably we can solve some problems. Sorry.
Thank you. Is there an immediate response to this? No. We agree. Disagrees. Okay, perhaps one issue, because from the point of deciphering volcanic unrest, many unrest episodes wane without an ensuing eruption, and very often you hear the terminology of false alarms. Nothing happens. My question is, are we, by using that terminology, are we not undermining our credibility with the public? Is there anything like a false alarm, really?
Well, you touched a very important issue, that is credibility. I mean, this is at the base of the relationship between the citizen and institutions. All this is very important to say, because citizens, if they trust in institutions, they do what institutions say to do, also in one night. If there is not this credibility, it's a problem. Because, and this I would like to connect again what I was saying with the social network. Because the social network is something that, if not well used, is going to yes, with the institution. Because we, in January of this year, we had a spontaneous evacuation in Garfagnana, because of an earthquake could occur during the night. And obviously, the institutions say it's not possible to say anything on that, but people were outside the houses because... And now the relationships between false alarm, institutions, and awareness, it's quite important. We must underline that the uncertainty, it's part of the game. We must say to people exactly what we are going to do and what we are going to say in a certain way, or what we are not going to say because we don't know it. And we must build this relationship, saying to people how the things are. This kind of problem we have got not just for volcano, we have for all the other risks. Another risk very common on this is the meteorological situation, the forecast. Now people expect to know exactly if tomorrow is going to rain, when, how much, where. And they are not used to understand that there are some signals that can be sharper, and sometimes we are not really sure what's going on. So we must facilitate people to understand that sometimes the science can be more sharp on that, but sometimes there is a big lack of uncertainty, and this is not connected with the credibility of the institution. It's just that simple, we're not sure.
I have two thoughts. First, on the terminology, I don't like the term false alarm either. I prefer the term false start. If you think about a race, athletic race, you know, the official says, get ready, get start, go. And sometimes the runner starts too early. And that's true with magma intrusions also. Sometimes the magma intrusion starts too early and it will not succeed to erupt. So then it stops. And I think we might play a little bit with the terminology to avoid the term false alarm. Maybe the more important point is related to what Fabrizio said. I think there's a very close relationship between the risk tolerance of a society and the kind of warning that we give, how early we give our warnings. If a society has very low tolerance for risk, then we must give warnings early. They demand that we give early warnings, and the chance of a false start or false alarm is very high. So if they have a low risk tolerance, they must also be willing to tolerate false alarms. Conversely, if they have a high risk tolerance, we can wait a little bit longer and have a better forecast. So I think it's important to try to have a dialogue between the public, those at risk, and those who are going to make the decisions, to try to, I call it a social contract between the officials and the citizens, to try to decide, okay, how much risk do you want to tolerate? And if it is low, then are you going to agree? You have to sign, I agree, to tolerate false alarms.
Okay, thank you. Is there a pressing need to add to it? Because we're approaching cocktail time. And we've got about half an hour left or so only before the boss leaves for dinner. Is that, or am I completely confusing the issue? 1:15, so about half an hour. So I think I would like to thank the panel, all of the speakers, and you for an exciting day. There's another day, there's day 2 tomorrow. So I think we all I personally learned a tremendous amount today, hopefully you as well. And let's go over and have some fun and cocktails. Okay. Thank you. Thank you.